Looks good.
All right, let's go. Hang on, let me just adjust this. Okay. Okay. Good afternoon, everyone. We are Zonnebloem. I'm June, and these are my lovely group members, Julia, Chris, Emily, Amy, and Aaron. So today we are glad to present to you what we have achieved so far. A quick overview of our design journey through the Bucky Lab. We actually went through 4 different phases. Firstly, to understand the problem, research through design selection, and then a design refinement phase. Each individual phase will then be further defined into smaller footsteps as we journey to the end. So let's begin. For a start, it is important for us to understand the main problem we are tackling. In short, extreme climates and self-protecting PV panels. Our group focuses on the very real possibility that as climate change progresses, extreme weather conditions will be more common than they are today. Hence, it is pertinent that Zonnebloem first protects itself, is durable, and be a visual inspiration for the masses towards sustainable design. Therefore, the important hard and soft criteria are as described so that we can achieve our design vision. Next, we look into a range of existing building typologies and site based on criteria such as the scale of operation, feasibility, and whether it is a standardized typology that can be widely implemented. Eventually, we narrowed down our selection to the furniture retail giant IKEA in Delft, largely due to its advantage of being firstly a highly visible building. It has a global scale of operation, therefore maximizing the potential of Zonnebloem in inspiring more people. With IKEA in mind, based on environmental and visibility studies, we determined the 2 southeast facades as ideal facades for implementation. Subsequently, we took a deep dive into the different solutions to broaden our horizons. First, we take into consideration the different climatic conditions and brainstorm corresponding solutions. And from all these, we eventually decided that the foldable shell idea is the one with the most potential in terms of being durable, being appealing, and it can be used in many different extreme climates. Therefore, this sprouted a whole new branch of explorations for us as we try to understand foldable and deployable how they actually work. And they can be categorized into 4 main types. So together with understanding how we retract the folds and how we structurally support them on the facade, we constructed a design matrix whereby individual types of folding can be matched with corresponding retraction mechanism and substructure system as shown in this diagram. And these 5 ideas that we brainstorm are the potential candidates for the final design. So with these 5 ideas, we will then further narrow them down into 3, where we develop in detail to fully understand how each of them work. And in a painful process we call killing our babies, we attempt to select the final idea to move forward with, and the difficult decision brought us to design number 2, which is a simple Mura fold on a guided linear rail. So while we were all quite sad, we had to forge on with the prototype testing phase, and we aim to resolve some of the unknowns within our final design, which most notably lies in the silicon hinges that we chose to make. So as we explored and tested various silicon profiles, we ended up buying all the black silicon tubes from 2 different Hama stores. And through a mixture of failures and sticky hands, we determined that the double flank open tapered profile best fits our objective of a unidirectional folding. So with the silicon hinges sort of resolved, we gained more confidence and momentum in building the final prototype for Zonnebloem, and therefore we constructed a 1:10 model to review the substructure strategy to visualize the folding of Zonnebloem on IKEA's facade using Arduino, as you can see in this diagram over here. And this is what the 1:10 model looks like. With the left, you can see the folding, and on the right, you can see how the Arduino is actually connected to the whole system to control the folding. Furthermore, this is a 1:1 model, which was constructed for us to verify our silicon hinge test. So shown here is the assembly process of how the various parts and components sort of come together within this 1:1 model. And ignoring my awkward moves, we were glad that the silicon hinges worked exactly as they did in the smaller prototypes. And it was truly a moment of relief for many of us to see it happen. So at the end of the day, we wanted to evaluate whether our original design intention whether this design actually met our original design intention. So we evaluated Zonnebloem against our hard and soft criteria and compared to a conventional facade PV. And we can conclude that Zonnebloem can potentially be more durable and perform better if these production processes were more refined industrially. And over the course of this project, we achieved the following goals and learned many valuable lessons revolving geometry, the design through research process, as well as ways to enhance the durability of our PV panels. And then furthermore, we have other areas of research that lies in the domain of refining the silicon hinges, integrating it with weather forecasting networks, and optimizing the components as well as testing its durability. And this brings us to our next part in establishing the widely asked question. So how durable is Zonnebloem? Firstly, we define durability within the context of the Netherlands, whereby resistance against hail and wind conditions is crucial. Thus, two separate tests are planned to evaluate its durability, the hail impact test as well as the wind tunnel test. A closer look into the experimental setup for the hail impact test, both a commercially available PV and Zonnebloem will undergo impact from hail with varying speed, size, and incident angle. And this is how the setup would look like. Furthermore, a wind tunnel test will subject the PV panels to wind from varying angle, wind speed, as well as different types of wind loads to simulate realistic wind conditions. Lastly, the durability of the PVs can be evaluated in determining the efficiency loss pre and post experiment. Damage assessment through the use of electroluminescence camera will also be conducted, and together they will eventually allow us to establish a scale of damage depicting how different extreme climates can affect the durability of Zonnebloem and what is its upper limits. At the end of the day, with this knowledge, we could then be better prepared for the extreme weather conditions which climate change will bring in the years to come. And from everyone in Zonnebloem, we thank you for being a part of our journey and for your attention. Thank you.